Hey guys, so today we are going to wrap up section 2.3 on those polynomial functions and their graphs, and we're just going to go through two problems and kind of going through everything that kind of puts this whole entire section kind of together. When we're looking at that leading coefficient to be able to tell us what directions our ends are going, looking at those degrees to knowing how many of those turning points there are and which direction those ends are going, figuring out our X-intercept, our Y-intercept, and then being able to graph this without the use of a graphing calculator. So we want you to be able to, these graphs aren't necessarily going to be perfect, but we want to be able to come up with a good representation of how these work so we understand the mechanics without having to use or rely on that graphing calculator. So we're just going to dive right in with the problem. And let's say we have f of x equals, I'm going to go with x to the third plus x squared minus 4x minus 4. And then over on the right, I'm going to kind of go through like what it is we're actually going to look for. So for A, we want to know about what that looking at that leading coefficient and our degree, what that's telling us about our graph, right? So our leading coefficient is the number out front. So technically on ours we have a positive 1 out there. So our leading coefficient is 1, and our degree is 3, right? We're looking for that highest degree on our exponent, which is that 3. So what do those two things tell us? Well, with a leading coefficient of a positive 1, we know that we don't have a stretch factor. With a degree of 3, having that odd degree, we know that our ends are going in opposite directions. And with it being that positive 1, we know that at the that on the right side of our graph, well, let's start with the left. Let's we write from left to right, so we're going to start over there. On the left side of our graph, we know that that is going to be falling, or it's going to fall, and on the right side, we know that it's going to rise, right? The second thing we need to look for, B, is going to be our X-intercept. So our X-intercept is when y equals 0, right? Our X-intercept is where we're crossing the x-axis. So when we look back at our problem, our original problem, and we want to find our X-intercept, our y is going to equal 0. The next thing we need to find is our X-intercept. And our X-intercept is when we cross the x-axis, and when we cross the x-axis, we know that our y value is always going to equal 0. So we're going to go back to our original function, and we're going to set y equal to 0. So for B, we would have 0 equals x to the third plus x squared minus 4x minus 4. So I need to factor this. I need to be able to figure out what my x is going to equal in order to make my y 0. So when I look at this one, it's not a quadratic, so I know I can't use the quadratic formula or try and factoring it. So with it being the third degree, I'm going to actually factor it by grouping. So back in the day, we did a whole section on these, right? So when I go to group them, I'm going to put these two together, and I'm going to put these two together because these guys got some 4's in common that I can factor out, right? So I'm going to go with x to the third plus x squared minus 4. Whoops, I'm going to put that in parentheses. Put my groups in parentheses. 4x minus 4. And of course that still equals 0, right? So 0 equals. So when I look at this little guy, what can I factor out? I can factor out x squared, and I'm left with x plus 1, right? Now I'm looking at my next little set. What can I factor out? I'm going to keep that negative, and I'm going to factor out technically like a negative 4. So if I have, so I need x, right, to get, and then to get to a negative 4, this has got to be a positive 1, right? because if we think of our distributive, when we go to distribute that, negative 4 times 1 is going to give me my negative 4. Right? So then now, as I continue on with my factoring process, now when I look at this whole entire thing, what do they have in common? They have that x minus 1 in common, so I'm going to factor out that x plus 1. Did I say minus 1? I apologize. X plus 1. And then what am I left with? X squared minus 4. X squared minus 4. So now I have it into some factors. So my zero product property says when I multiply, one of these has got to equal 0. So I know that either x plus 1 has to equal 0, or my x squared minus 4 has to equal 0. So from here I'm going to get x equals negative 1. From here I'm going to add 4 over to both sides. Then I'm going to take the square root, right? The square root of 4, and so that's going to give me x equals a positive or a negative 2, right? You could have gone through and factored this to where, you know, and you would have came up with x plus 2, x minus 2, and then when you solved it, you'd get x equals 2 and x equals negative 2. So when it comes to my x-intercepts, I have an x-intercept when x equals negative 2, when x equals negative 1, and when x equals a positive 2. Okay? For C, whoops, I'm gonna run out of room, I think. For C, they want us to find the y-intercept. So the y-intercept is where we cross the y-axis. So that would be when our x equals 0. So for C, I'm going to go back to my original function, right? My y equals x to the third plus x squared minus 4x minus 4, but now I want to plug in 0 for x. So y equals 0 to the third plus 0 squared minus 4 times 0 minus 4, and we can see that y is going to be 4. So my y-intercept is going to be when y equals 4. And then our last piece is actually part E. We are skipping D, which has to do with it being odd, even, or neither when it came to symmetry. So we're going to skip to E, and E has us graphing these. So we're going to fit it in. It might be a little on the tight side, but we'll get it in there. So 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. So what I'm going to do is I'm going to go through and I'm going to mark my important points that I found out. So I know my x-intercept was when x equals negative 2. So I know that's an important point. When x was negative 1, that was an important point. And when x was 2, right? So that took care of my x-intercept. So I know that my graph has to do something with those 3 points. And then also my y-intercept, and I lied on my y-intercept. When I put in 0, I apologize, you get negative 4, right? So there should be a negative 4. Right? And then I'm going to cross the y-axis at negative 4. Thank you for letting me know that that should be a negative 4. I apologize. All right. So now I'm going to go back up to A when A was telling me about my leading coefficients. And then I know that my degree was 3, so I'm going in opposite directions. My leading coefficient was that positive 1. So on the left, I'm going to be falling, and on the right, I'm going to be rising, right? And then the other thing I just need to check on is, am I going to go through these points, or am I going to touch and turn? So when I look at my x-intercept, the multiplicity was 1, right? So this is going to go through or pass through. I like pass through better. So this is going to pass through the axes, right? And actually the same thing is going to happen with both of these because they all had that multiplicity of 1. So I'm going to pass through those points. So making a cheesy kind of graph of this, I know that the left side is going to fall. So it's going to go down and it's going to come up through that point, and then I'm going to hit that point, and I have to turn somewhere up here to come back through, to go back through, pass through my -1. I'm going to come down to -4. I'm going to come somewhere down here, and then I'm going to turn and I'm going to come back up through where x is 2. And I'm going to make sure I have arrows at the end of my graph, because my graphs are going to continue on, right? And then if I wanted to get a little bit more specific on this graph, a little bit more concrete, I could sit there and I could more accurate. If I want to know like where that maximum point actually is, it's going to be in between that -1 and that -2. So I could put in, you know, -1.5 into my function, and it will tell me what my y is, and then I can make sure that that point is a lot more accurate than what it might be right now. Same thing over here. Like if I wanted to put in 1 to sit there and see where it's actually going to cross on the y, because this technically could have came down maybe a little bit more and came up. Probably not because of it, but still, you could put in additional points to sit there and make your graph a little bit more accurate than a rough sketch, right? All right, let's just do one more example of these. We'll run through this one maybe a little quicker. There, you can just watch me in twice the speed, right? Let's say we have, let's use f of x equals -x⁴ plus 16x squared. Okay? So the first thing we want to talk about is our leading coefficient. Our leading coefficient is -1, and our degree equals 4. So degree 4 tells us that we're going to go in the same, our ends are going to go in the same direction, and that leading coefficient being -1 is going to tell us that they're going to go down, right? So the left is going to fall and the right is going to fall, right? B was finding our x-intercepts, so that would be when y equals 0. So when we look at our problem, we want to put y equals 0. So for B, we would have 0 equals -x⁴ plus 16x squared. So I need to figure out how to factor this baby so I can get my x's all by themselves. And first thing I always do is there a common term that can be factored out of all of these? And there is. And I am going to factor out a -x squared. So that's going to leave me with what? X squared minus 16, right? And then I can make a choice. I can either go ahead and factor this guy out to x plus 4, x minus 4, or because I already have my factors that are being multiplied, I can set these guys equal to 0. So I'm going to set -x squared equal to 0 because my zero product property. And I'm going to set x squared minus 16 to 0. Right? I'm going to take the square root of both sides of my -x squared equals 0, and I'm going to get 0. But I'm going to write it as x equals 0 and x equals 0 because I technically have it happening twice, right, because of it being squared. This guy, I got x squared equals 16. I'm going to take the square root of both sides, and I'm going to get x equals plus or minus 4, right? So now when it comes back to our multiplicities that we were talking about, right, this guy has a multiplicity of 2. So what does that mean? That means that it's going to, remember, touch and turn. And here we have a plus and a minus 4, so each one of those has a multiplicity of 1. So that means it's going to pass through our graph, right? All right, So X-intercepts, we can fill that in over here. So we know that was when X equaled 0, right? And we can even write on there if you wanted to, multiplicity of 2 to remind you. X equals a positive 4 and X equaled a negative 4, right? And both of these had a multiplicity and these had a multiplicity of 1, right? C was the Y-intercept. So the Y-intercept is when X equals 0. So we're going to go back to our original equation and we're going to put in 0 to the 4th for our x's plus 16x squared, or we can just see what's going to happen when we put in a 0 for these guys. What are we going to get? Y equals 0. Yep. So our Y-intercept is when Y equals 0. A, B, C, we're skipping D, and then we're going to go to E, which is where we're going to graph this guy. Alright, so I'm going to mark my important points. So I know that I have an intercept when X equals 0. I had an X when negative 4, and I had an X value of 4. And then I also had a Y-intercept where Y equals 0, so that's that point as well, right? So we got 3 points. We know that our leading coefficient was -1 with that degree of 4. So we know that both ends are going to fall. They're going to go in the same direction. So that's telling me I'm going to come through here, right? I got to turn, because multiplicity of 1 we go through. So we pass through -4. And then somewhere around the lines we're going to turn. And when we turn, we're going to come to where X equals 0. But what are we going to do at 0 with the multiplicity of 2? We're going to touch it and we're going to turn and go away, right? Then we're going to go up. And then we got to come down somewhere in order to go through 4, and 4 is multiplicity of 1, so we're going to go through it. So we got some arrows on our ends, right? And then just for the fun of it on this one, we're going to actually check this out and see, did I go up high enough on my graph? So I know I crossed at 0 and I crossed at 4. So I'm going to try at 2, because 2 technically should be that maximum value, right? So what happens, and you can either use the -2 or the +2 because it's going to be symmetric. So I'm just going to use the +2. So I'm going to go back to my original equation, right, of f of x, and I'm going to put in 2. So f of 2 of -x to the 4th plus 16x squared. What am I going to get? I'm going to get -2 to the 4th plus 16 times 2 squared. So f of 2 equals -2 to the 4th is 2 times 2 times 2 times 2, which is going to be 16, plus 16 times 4. 16 times 4 is 64, right? 32, yep. And then f of 2 is going to equal 58. Whoa! So really, when it came to my graph, I should be way up, well, way up, right? So making a nice little mess of this, I really should have been like way up here somewhere and came back down to 0, and then went way up and came back down, right? And I can erase these little guys. Right? So that's why it is important though in times to when it comes to those, like, granted this probably still isn't up to 58, but it's kind of getting there, right? So sometimes we want to check those numbers to make sure we can get this a little bit more accurate than what we think it should be. All right, so I think you guys have I think there's 10 problems for you guys to work on. When you go to factor, check it out. See if you can factor a like term out. Look for those perfect squares. All those good things of those algebra factoring skills we're good at. All right? That's all I got for you.